again, here we have a transformation that looks like that matrix, and it's applied, and the image of a curve is that. Find the original curve. Okay. So what's happening here is that we've got this matrix, 3 over 5, 4 over 5, minus 4 over 5, and minus 3 over 5. It's being applied to something, and we get an image. Something like that. Now the image curve is given by this, which is another way of saying that we've got x dash squared minus 2x dash y dash minus y dash squared equals 4, because that's the image, and these are our image points. From our matrix here, we could just multiply this out, and when you multiply out this matrix against xy, what you find is that you get 3/5 of x plus 4/5 of y equals x dash, and you get minus 4/5 of x minus 3/5 of y equals y dash. And then we will substitute, instead of x dash in this equation here, we will write in all of this, and then we'll square it and so on. I'll just write this out so it looks a little bit simpler than that, because we're going to be doing a lot of dividing by 5s here. So x dash equals 3x plus 4y over 5, and y dash equals negative 4x plus 3y also over 5. I just do that because I'm going to be squaring it here, and I don't really want them in separate parts. I want to combine them all, so square my fifths and stuff. Okay, just thinking ahead a little bit. Here we go. Let us now, what I'm going to do is put our numbers into here with the substitutions we've got here, and just see what it all comes to. Okay, x dash squared, so we get 3x plus 4y over 5 squared minus 2 into x dash 3x plus 4y over 5 times y dash, which is minus 4x plus 3y over 5, and finally minus y dash squared, so minus 4x plus 3y over 5 squared, and that lot equals 4. We've got to make this look as simple as we can. Okay. We're going to get a lot of 25s on the bottom here, so I might as well, I'll do it as I go along, and then I'll combine them in a minute. Okay, this first part is going to be over 25, because 5 squared is 25, so we're going to get the square of the first, 9x squared, double the product, because we're squaring 4 3's, 12, we're going to get plus 24xy, and square the last, plus 16y squared. Now we're going to get a minus times a minus here, so this is going to be all plus in this one, and it's going to be, again, 25 on the bottom. 3x times 4x is 12x squared times the 2, so that's going to plus 24x squared. I'm just doing it all at once. 3x times 3y is 9xy doubled, so plus 18xy. 4y times 4x is 16xy doubled, that's 32xy, and 4y times 3y is 12y squared doubled, is plus 24y squared. Finally on the end here, now this minus is within the squaring sign, so this minus will get squared out to become positive. We're still going to get a minus though, so we're going to get minus, again it'll be over 25, and it's still going to equal 4. Right, but that one on the inside will disappear, so we're going to get, well, not disappear, it gets squared, becomes positive. 4x squared is 16x squared. 4 3's are 12xy plus 24 3 squared is 9. I mean that's got to go to negatives. Okay. Let's multiply everything by 25, then we get it equal to 100. Then, combining, we've got 9x squared plus 24x squared, that's 33x squared. 33 minus 16, 33 minus 16 is 17 x squared. Let's just say 24 minus is 8 and 9 is 17. Okay, so there's the x squareds. Now the xy's, we've got plus 24 plus 50, because 32 and 18 is 50, so that's 74 minus 24. That's plus 50 then. 50 xy's. And the y squared, we've got 16 and 24 is 40 minus 9 is plus 31 y squared, and that's everything. Oh, I could have written that over here. And that's it done then. This is I'll write a statement at the end here. So this is the original curve. Yeah, okay. Original curve is 17x squared plus 50xy plus 31y squared equal to 100. So the algebra is a bit fiddly and awkward. You've got to be really careful you don't lose bits and pieces in there, but the basic idea is that this is the transformation matrix and it applies to your point. They're the source points, so that's the source, and you end up with something, and that's the image. Now because they're the image points, and this is the image curve, we can just think of that as being that curve with the image parts of it, and then just use the substitution which we get from multiplying out that matrix.